Hi guys, thanks so much for joining this session today. I know you're probably tired. There's already been a lot of sessions today, so I appreciate you sticking with me here. For anyone who doesn't know me, I don't know, you might have seen me at a previous code camp. As I said, this is, I think, number 5. So I've been here a fair amount of times. But my name is Grace Jansen. I'm from the UK, and I work for IBM, primarily in sort of the Java space. Have I got any Java developers? Yeah, a few hands. Yeah, great. Okay. Some of you were like, yeah, I guess. Cool. So yeah, I work in the Java space, mostly in open source technologies, which I absolutely love. I love being able to sort of share the stuff that I work on quite easily and let you guys have a go with it too. Hopefully I'm going to show you a little demo later on if my Wi-Fi connection works to my phone, which hopefully it will do. So today I'm going to be talking about how do we become a cloud-native doctor. So for anyone who doesn't know me, I actually did a biology degree before going into tech. Fish has really helped me with Java development. So I love to be able to try and make biological analogies to software and sort of complex architecture issues if I can, because it helps me at least to kind of get it clear in my head, especially when they're quite abstract concepts that can sometimes be hard to get our heads around. So I was like, okay, how do I get my head around being able to understand what's going on in my application when it's distributed, and as Mark and Neil have been saying time and time again, complicated, it's complex, it's hard. How do I get about being able to effectively understand what's going on in real time in my application? And that's where I kind of found this analogy between medicine and software. Obvious, I know. So we're going to get into how we become cloud-native doctors, what we can learn from medicine and take that into our own applications to hopefully make them more effective when we're deploying them into production and deploying them to the cloud. So without further ado, we'll get started. So what can we learn from medicine? It takes years and studious hours to become a doctor because they have to learn to be able to understand complicated metrics and to be able to analyze those metrics, often without a lot of understanding of what's going on outside of those metrics, to be able to actually understand what's going on with the patient, diagnose them, and come up with a solution. Those metrics can include things like physical symptoms, if my arm's falling off, that's kind of an obvious one. But there's other non-obvious ones, so it might be a combination of written doctor notes, things like heart monitors, blood oxygen level. Think of, sitcoms and all the buzzing machines that are behind patients whenever they're in the hospital, which inevitably always happens. So doctors are constantly trying to monitor a bunch of different metrics and understand, okay, what do these metrics actually mean under the covers? What is wrong with my patient and why? And what can I do to fix it? And that's exactly what we're trying to do in software development. When we're deploying our applications to the cloud, whenever we're seeing all of these metrics, so whether it be API requests, our application health, how long it's taking for a request to go through, memory consumption, CPU consumption, all of these are key metrics that we're probably already collecting for our application. If you're not, definitely check out metrics, would recommend. But the difficulty with just collecting metrics, so let's say I'm a doctor and all I get is that heart monitor or that blood oxygen level. It can be quite difficult to look at that and to immediately know what's wrong with the patient. And that's because, let's take an example where I'm diagnosing an adult. Diagnosing an adult is far, far easier as a doctor than diagnosing a baby. Anyone give me an answer as to why? And you can't just say it's because they can't talk. Yeah, I've got a hand. They are different in terms of biology. And babies are a bit more complicated with their bones aren't fully transfused and, their brains are still developing. But actually, the answer I was looking for was context. An adult, okay, it kind of relates to the talking element, but an adult can give a lot more context in terms of, oh, I fell over and I bumped my head, which is probably why I'm feeling dizzy. It's probably why I'm feeling faint. It might be why my oxygen levels are low because I'm not breathing properly because I had a bit of a scare. So adding in that context gives us a lot more information as to what those metrics actually mean, why they might have happened, and how we can solve it. And it's often this context that's missing in our applications. How many times have you looked at, say, a Grafana dashboard, you've looked at the metrics on there and go, okay, I know what the problem is, but I have no idea where it's going wrong. And that's where this context comes into play, being able to give us that understanding of where in a particular request something went wrong, where in a particular transaction something went wrong, so that we're able to better debug and better solve problems or bottlenecks or failures in our application. So that's what we're trying to do when we become cloud-native doctors. We're trying to follow the same patterns they use in medicine. We want to be able to get not just the metrics and the data and the pure numerical stuff. I know we love that as engineers, but we do need a bit of context in there as well. So we need to be able to involve context in our applications so that we can be more effective in diagnosing them. So how do we do that? Observability is the answer. So when I say observability, I don't just mean logs and metrics. We're taking this a step further and going towards that context element in tracing in our application as well. I'm going to show you how you can do that with Open Telemetry in this session today. So when it comes to enabling observability, there are 3 key steps. There's instrumentation. So when I say instrumentation, I mean actually enabling our applications to give us the data we need. So enabling logging, metrics, traces within our application. So that's step 1, to be able to actually collect the relevant information we need. Step number 2 is, okay, now that we've got this data, we need to actually send it somewhere so that we can then have an external system store it, analyze it, and then we can start to understand it. So sending the data. The third step is, okay, now that I've got this data, it's all well and good, but how do I actually understand it? And that's when visualizations come into play. So I was talking earlier about things like Grafana dashboards. You might be using Prometheus, Kibana. There's tons of different tools out there that enable you to be able to take this numerical data and show it in that visual format so you can more easily see trends within your application. So this is step 3, being able to actually understand and identify what's going on with visualizations. Now, if I was going to try and cover all 3 in one session, you would be here all afternoon. So don't panic, we're not covering all 3, we're just covering this first one, which is instrumentation, because really, that's at the core of, when we're developing applications, what we can actually impact. Because often we can use tools, external services, to be able to actually achieve steps 2 and 3, like Grafana, Kibana, FluentD. There's lots of different dashboarding tools and sort of tools out there to collect, analyze, and visualize our data. But unless we have the data, there isn't much point in those tools in the first place. So how do we actually collect the relevant data? Well, there are 3 different pillars within instrumentation, within that first step. I like to sort of have it as kind of like, I guess it's kind of similar to the building outside, which I saw earlier. That was beautiful, the Roman building. So you've got those pillars that are kind of holding it up. These are the pillars that are holding up observability. We've got the first one, which is logs, second one, which is metrics, and that all-important third one, which is tracing, which may be the element you haven't quite introduced in your own application yet. Now, that's not to say these are the only pillars of observability. They're just the core 3 that are included in many of the open source specifications that are out there at the moment, like Open Telemetry. There is hopes that in the future, they're going to expand that to include some of these additional pillars. For example, profiling and end-user monitoring. So literally having a live session of, okay, how do my users use this service, for example, what happens, and monitoring that request in real time. Profiling as well. So there's lots of different additions that we could add to this, but right now we're just going to stick to these 3. So logging, metrics, and traces. Logging. Who doesn't use logging? I'm hoping there's no hand. Oh, there's 1 hand in the room. You were brave. Thank you, sir. I appreciate that honesty. Please consider logging. So logging is a fantastic first step, okay? And there are lots of inbuilt tools, I promise, that you can utilize to be able to achieve logging. Logging is essentially just a time-stamped message. It normally emits things like errors, warnings, and normally they're stored in a set of log files. So normally they're not necessarily associated with any particular user request or transaction. They're literally just a message that's kind of sent out, stored, and captured. They're fairly straightforward, fairly simple, and they're a good first starting point. However, they have their limitations. Normally, as I said, it's a time-stamped message. So normally you don't get a log message that gives you characteristics or behavior over a period of time. Normally it's just at a snap second within that application running. So it doesn't give us much insight into how that behavior might change over time. And that's where things like metrics can be useful. So building on top to the next pillar, we've got metrics, which some of you may be using, some of you may not. I'm not going to ask for hands this time, but I really appreciate you. So metrics allow us to take that step further and not just have a time-stamped message, but have numerical data over a period of time. And what that allows us to do is to be able to see that behavior change over time and understand why that behavior change might be occurring. It includes things, I've already mentioned some of them, like CPU utilization, memory utilization, API requests, as you can see. And what it allows us to be able to do is to be able to analyze that and come up with trends and insights based on that data over time. If you are a Java developer, which I saw some hands earlier, so hopefully this interests you, there are tools that you can utilize to be able to achieve metrics in quite an easy way. Has anyone heard of MicroProfile before? Yeah, I got a few hands. Thank you, guys. Only a couple, though. So I'm glad I've got this slide. So MicroProfile. MicroProfile is a community-driven specification that was designed and developed to really bring enterprise Java into the modern world. So it introduces a lot of cloud-native APIs that you can make use of that are really designed to enable you to make effective microservice-based cloud-native applications. So it includes things like Open Telemetry, which we will get onto. I've kind of predicted myself there, but also things like reactive messaging, Open API, and some common shared with Jakarta EE. So Jakarta EE is another community-driven specification. It's basically the open source of Java EE, and it enables things like RESTful web services, JSON-B, JSON-P, REST client, and it also enables external configuration as well. But the one for this one I wanted to talk about was MicroProfile Metrics. So if you've not tried it before, check out MicroProfile Metrics. It enables you to be able to have a wide array of different metrics collected on your application, and it's quite easy to use, and it works with lots of different vendors, which is the nice thing. Sorry, you were taking a photo. I've gone back. You sure? All right, so compatible runtimes. This is the nice thing with specifications like MicroProfile and Jakarta EE. There isn't vendor lock-in, which you do get with some alternatives. So the nice thing is if you build your application with APIs like MicroProfile and Jakarta EE, the same applications will work regardless of which runtime you run them with. And it means you get greater flexibility and portability of your application as you're moving it, say, from one runtime to another, or if your teams are using different runtimes in different applications, for example. This is the latest versions I looked up. This table might not be completely up to date, but it is up to date as far as I'm aware. Let me know if it's not. If you're a big, Pyara fan, and you know something I don't, please let me know and I'll update the slide. But essentially what it means is there's lots of different major versions of MicroProfile, and they offer different versions of those APIs, and as you can see, lots of different compatible runtimes. And as I said, metrics is the one you want to look out for if you haven't already enabled metrics within your application. So do check it out. We have a guide on that. I'm going to show you our guides. I'm going to demonstrate one at the end. We have a website called openliberty.io, and on there we have lots of interactive guides. The nice thing is we spent a lot of time trying to make them so you don't have to do it locally if you've got a restricted machine, because we know a lot of people can't download whatever they want on their own machine. So we've made a browser-based environment so you can try them all out in about 20 minutes if you do want to have a go with that, and I'm going to demonstrate one later. Okay, moving on to the last pillar, because this is the one we're excited about. Tracing. Who's excited about tracing? Woo! It's like 4 p.m. in the afternoon. Tracing! Okay, so what do I mean by tracing? What I really mean is distributed tracing, but we're just going to shorten it for today because it's 4 p.m. It's just tracing. So what we mean is this is really about not just recording, logging, or metrics, but being able to record the path a transaction or a request takes through multiple different services. And the important thing is that this is all about being able to capture that all-important context, which I'll go into in a minute. So this is the important step we need to take if we're going to go more towards that medicine route and really understand why something is happening, not just what's happening. So in here, as I said, this is really because more and more of our applications are becoming distributed, they're becoming microservice-based, macroservice-based, even serverless, and it's becoming harder and harder and harder to actually understand where something goes wrong in that particular transactional request. So there are some key concepts to understand when it comes to tracing, key definitions that you'll need as we go through this sort of interactive hands-on lab in a minute. The first one is, what is a trace? So a trace here, what I really mean by that, it just represents requests, and it normally consists of multiple spans. So you can see the diagram on the right-hand side there. The orange, it represents the trace. What is a span? A span normally represents a single operation in a request, and normally it contains things like name, time-related data, log messages, and any metadata that we might need to give us information about what's occurring during a transaction. So multiple spans make up a trace, and you can see those represented in pink on the right-hand side. And this is the all-important part here, context. This is what we're trying to introduce. So context is an immutable object that's normally contained within the span data to help us to be able to identify the unique request that that is a part of. The data normally consists of two different things. You've got the span ID and you've got the trace ID, the parent ID and the trace ID. So the trace ID, this is normally the same trace information. It's a unique identifier that allows us to understand that that particular span is part of that particular trace. So we know it's all part of the same request or the same transaction going through our application. The parent identifier is actually the span ID of the parent that spawned the current operation. At 4 p.m., that was easy to digest. Okay, it's a bit easier in the diagram here. So as you can see, I've got my information in the purple there. That's my context. And as you can see, my parent ID for that first bit of context I'm providing is the same as the span ID from the parent that spawned that particular process going on there. So it's ABC123, and then that changes as we get to the next service and we get another context change. So now we've gone to DEF456, originally named. So you can see here how this context can help us to understand, okay, whereabouts in my transaction did something go wrong, and to really drill down when we're debugging to understand why that went wrong and give us the important context we need to debug effectively. So that's why adding tracing into your application is really important. How? That's the all-important question. There's been a lot of theory, but not a lot of practical. So we're going to get on to the practical. Open Telemetry. This is an open source specification that has basically been born out of a need to have a standard for all of these things. So in the past, the way in which code was instrumented would really vary. Different observability backends each had their own instrumentation libraries, and it became really complicated. You had to learn a new one every single time you wanted to switch observability backend. You had to reskill, you had to re-architecture, recode. So we really needed a standardized data format to be able to send observability data to and from different components in our applications. So Open Telemetry was kind of created. This was a joint project between Splunk, Google, Microsoft, Amazon, and many other organizations. So some big players involved here. It's now it's got the second largest number of contributors in the Cloud Native Computing Foundation, just after Kubernetes. So it is a really active project that's getting a lot of sort of notice at the moment and is being really sort of picked up by a lot of different companies. Open Telemetry actually offers sort of a pluggable architecture that allows you to be able to add technology protocols and formats easily. It supports lots of different open source metrics formats. So for example, Prometheus and others, for example, you can utilize Jaeger and Zipkin with this to be able to store and query your tracing data. The idea is you'd use this to instrument, generate, collect, and export your telemetry data to then help you analyze your software's performance. Originally, there were two different open source specifications, Open Sensors and Open Tracing. They kind of focused on different elements of observability data, but the issue with these two was that we had two. There was still not one single data format that was standardized. So kind of missed the point there. So what they did is they decided to take the best elements from each of those open source projects and to combine them together to make one standard, which is kind of the definition of standard. So it then created Open Telemetry. So these two projects, if you are already using them, or you were considering using them, they are deprecated, they are not being developed anymore. So please look at Open Telemetry instead, because that is the project that's being developed. It's a collection of tools, APIs, and SDKs, and it basically just enables us to have this standard to collect the observability data we need. It includes things like logging, metrics, and the all-important tracing that we want. Now, one thing to note here, and there's a reason I put this last bullet point on the slide, Open Telemetry is not, I repeat, it is not an end-to-end observability backend. Open Telemetry helps with that first step. If we go right back to the beginning of this presentation, that instrumentation step, instrumenting our apps. What it does not do is it is not a tool to send, analyze, or visualize that data. So you will need to use it in conjunction with other tools like Jaeger, Zipkin, Prometheus, Grafana, and all those lovely things. So do bear that in mind if you're thinking about using it. Don't assume it's going to do everything for you. It's not magic. It's just helping with that first step. The way it looks is a bit like this. So on the left-hand side, you can see, for example, our microservices are up there in the top left. We've also got some infrastructure that we want to collect some data from to really understand what's going on. What we're using is OTLP, which stands for the Open Telemetry Protocol. We love acronyms. I swear half the time it's like Latin, just having to translate everything. So OTLP is what we're using as that standardized data format to send our data to this central collector. That collector, I'll talk about in a minute, but that's where we're going to do anything like batching, if we want to do any security, things like that. It's like additional sort of central stuff that we don't necessarily want our app to be concerned with. And then once we have that, we can send it on to basically any observability front end we want. As I said, Open Telemetry supports a lot of different data formats and different sort of tools and technologies that you can make use of. I talked about the collector. So the Open Telemetry collector it's basically what it does is offers a vendor-agnostic implementation of how to receive, process, and export telemetry data. It removes the need to have multiple different agents and collectors, which you may have had before. You might be wondering, sort of, under what circumstances do I actually need a collector, though? Can't I just send my data with the standardized format straight to the front ends? Okay, so for trying out and just getting started, if you're just trying out Open Telemetry, sending your data directly from a back end to a front end is totally fine. You can do that. You can use the Open Telemetry protocol. But the issue with that is that, if this is a development or a small-scale environment, you'll get pretty decent results without a collector. But if you're using this in an enterprise environment, in a production environment, we generally recommend using a collector and not just sending it directly through. And that's because, as I said, it allows your service to offload data really quickly, and the collector can take care of any additional data handling you need. Like I mentioned, batching, encryption, or even sensitive data filtering. So all of those things can be handled by the collector and don't have to be handled by your application. So I would recommend, if you are considering using this in production, do consider using a collector. You can use different collectors, but this is the Open Telemetry standard one that you can make use of. And you can see some of the sort of additional data handling that's happening in the middle here. But as you see, you can accept data from lots of different sources and send them to lots of different sources too. Okay, so that's Open Telemetry. But how do we use it? Because Open Telemetry is, at the end of the day, still a specification. So if we want to make use of it, we need an implementation to actually use it in our applications. I mentioned MicroProfile already. Big fan. I've got it on my t-shirt somewhere. There we go. I just love it. So Open MicroProfile, come on, you've got to have passion. MicroProfile has a brand new API that makes use of the Open Telemetry specification, and that is MicroProfile Telemetry. Now, a word of warning here. MicroProfile Telemetry only implements one part of the Open Telemetry specification, and that's tracing. It does not yet enable Open Telemetry metrics, for example, although that is in the pipeline, so watch this space. It's exciting. But right now it is just tracing, so bear that in mind if you're looking at using this. You'd need to use something like MicroProfile metrics if you wanted to use that specification to enable metrics in your application. But again, watch this space, because that's going to change to Open Telemetry metrics at some point. So it's all going on in MicroProfile. It's quite an exciting and innovative space. If you want to contribute, we're always looking for open source contributors. There's lots of first contributor issues out there if you want to have a go. Okay, so what is MicroProfile telemetry? So this was introduced in the latest major version of MicroProfile. As I said, it implements the Open Telemetry specification. And again, it's a set of APIs, SDKs, and tooling and integrations that allow us to be able to collect and manage those traces that I was talking about. The way it works is there's 3 different types of instrumentation you can use in your Java applications if you want to make use of this. The first one is automatic instrumentation. Really easy, especially if you're already making use of Jakarta EE. So if you're using Jakarta RESTful Web Services or MicroProfile REST clients, these are 2 other APIs from the Jakarta EE and MicroProfile specifications, you can already use automatic instrumentation. You don't even need to change any code. It's that easy. I'm going to show you, hopefully, if my Wi-Fi works. Okay, second one is manual instrumentation. So that can be added via annotations. If you're familiar with MicroProfile, you'll be familiar with annotations because they use them everywhere. So you can use the annotations with span, or you can do it with CDI injection, which is another API you can use from MicroProfile. So you can use the @inject tracer or @inject span, or alternatively, because we just love options, you can do a programmatic lookup as well. The third and final option from implementation is using an agent instrumentation. So using Open Telemetry Java instrumentation to gather that telemetry data, again, without any code modification. The way that it works is very similar to the diagram I showed you earlier. So this is an example application. So here we have requests coming in. We've got 2 microservices. We've got some traces and requests going through both of them. And we're collecting that context, including it within our spans, and sending that via the Open Telemetry protocol to our backend exporters. In this case, we're going to use Jaeger in my demonstration. But we're developers. We're an opinionated bunch. Use whatever you like. You don't have to use Jaeger if you don't want to. So, demo time. I think I've got time. Yeah, I do. Perfect. Okay. So, in this demo, we're going to be using Open Liberty. Who's heard of Open Liberty? Oh, nice. That was a super keen hand. Yeah. Thank you. I appreciate that. Few hands in the room. Okay. If anyone hasn't, it is an open source cloud native runtime. I'm literally wearing the t-shirt. So you can check it out, openliberty.io. It's really built to allow you as developers to focus on just your code in your application. It's designed to be really lightweight and easy to use. So here's another question. I always love this one. There's a big difference here. Who's heard of WebSphere? Yeah, a lot more hands. Thank you. It's usually the typical response. So WebSphere was our sort of IBM's kind of traditional web application server, and it served its purpose. It was great in its day, I'm going to say, but it's a bit big and bulky and heavy for the cloud. So we realized that we needed to re-architecture it, make it much lighter, make it modular, make it much easier to use. So that's when Liberty came about in 2014. And then in 2017, we open sourced it. So that's how it became Open Liberty. So it offers many of the same features and functionalities that you would have gotten in WebSphere without all the bulk and the hard to use parts of it, which is quite nice. So that's what we're going to be using in today's sort of example. If you don't know much about Open Liberty, I've got an article. I'm going to share my slides afterwards, so you can click the links after. You don't have to take pictures and type them out. But yeah, you can check out more about what makes Liberty great in that article. As I mentioned, we have interactive guides. So these are on the Open Liberty website. I help make them. Please check them out, because we spend a lot of time doing them, and hopefully they're helpful. Otherwise, it's a bit of a waste of time. But in this case, we're going to be focusing on the observability guides that we have. I think it's over like 64 different guides. So lots of different sort of educational material there. If you're unfamiliar with MicroProfile or Jakarta EE, we've got guides on each of the APIs offered in that specification. So you can go through and try out the ones you're interested in, like metrics, for example. As I mentioned, you don't have to do this locally on your own machine if you don't want to. We do have a browser-based environment. It's based on a Thea-based IDE. And what it means is all you need is a browser, and you can get started in about 5 minutes. We do require you to sign in. We didn't originally, and then Bitcoin miners found us. And now we have to have a login. So you do have to log in, but you can log in with lots of different social logins, like GitHub, which hopefully, as developers, we probably all have an access to. So that's what I'm logging in with today. All right, I'm just going to switch over. Looking at my guy. Thank you. Brilliant. So you don't see the sort of behind the curtain magic. Thanks very much. So smooth. Nice. Okay. So this is the browser-based environment that I was talking about. So to get here, I just went to the Open Liberty website. You can see the guides here. As you can see, loads of different guides on lots of different topics. We have this button, Run in Cloud. If that is shown on any of the guides, it means you can use our browser-based environments. There are a couple that you won't be able to use our browser-based environments for, and that's generally because it gets a bit complicated using a cloud environment when you're deploying something to a cloud. It gets a bit like meta and hard. So some of them you have to do locally, but the one we're doing today, you can do online. So I went to the observability section, and this time we're doing the Open Telemetry guide. You'll be pleased to know, because we've been talking about Open Telemetry. And on here, you just click the Run in Cloud option. If you want to run it locally, that's absolutely fine. You can follow these instructions, and it tells you the prerequisites you'll need on your local machine at the top right-hand corner for all our guides. You just scroll down, and it will show you the code you need on the right-hand side. But I love doing it in the browser-based environment, because I think it's quite cool. So we're going to go into there, and I have already set this up because to save time and network. Am I still connected? Yes. Okay. So in here, what you'll have is on the left-hand side, you have all your instructions. On the right-hand side, you have your Thea-based IDE and your terminal in the bottom right. So it means you don't have to leave this. You can do everything inside this environment, which is nice. The other thing we have is, I'll go to the next one. For each of our sort of commands that we need you to do during this, we actually have a copy and an execute button to make it really easy. Because I don't know about you, but I'm a lazy developer most of the time. So I just want to click the execute button and be done with it. So we try and make it as easy as possible. So we have that in there. With all of our applications in our guides, we try and make them simple. So it's the technology you're learning about that you're getting your head around, not the application. So we use the same application for almost all of our guides. It consists of 2 microservices. You've got the inventory microservice and the system microservice. Your system microservice is just scraping your system data every 15 seconds. It's fairly straightforward. Your inventory microservice is just collecting that data from the system microservice and storing that in an inventory. So they're fairly simplistic microservices. The idea is not to show you an enterprise application here. It's just to allow you to get started with this technology. So in this, what we're going to be doing is taking these 2 microservices and showing how you can get started enabling Open Telemetry in your application. So the way that we do this is we have all of our guides are on GitHub. So right now, I've cloned the repo already. I'm going to make that a bit bigger so you can see it. There we go. So I've already cloned the repo. Now, in all of our guides, we have the same repository structure. So all of them will have a start and a finish directory. The start directory is where you're going to start, hence the name, and it's an incomplete repository. So you're going to need to do steps to make it complete and finish the guide. If you want to cheat and skip straight to the end, that's also allowed. We have the finish directory for that. It's also there in case you do anything wrong, you've created a bug somewhere, and you need to compare it to what the code should be like. So it's there as kind of guardrails for this sort of development activity. But yeah, that's the same directory structure we have for all of them. So right now, what I've done so far is I've cloned the repository, just to save time, and I've also started up Open Liberty, my runtime, for both microservices. So for this, what I did, let me go to the next slide. What I did was use this Maven Liberty dev command. So we're using Maven for this particular, as our particular build tool of choice for these guides. We've done them all as Maven, so you don't have to worry about context switching between different build tools when you're looking at different guides. Now, if you want to use Gradle, that's totally fine. We work with Gradle as well. If you really want Ant, totally up to you. But I'm using Maven here. What the dev command allows us to do is to run Liberty in dev mode. I could have just done maven liberty :run, and that would have just run my server. But what that means is if I make any code or configuration changes, I'm going to have to tear down my server and redeploy it if I want to actually see those changes in real time. Instead, I'm running it with dev mode because what this allows me to have is basically a hot reload function. So it listens out for code or configuration changes, so I don't have to tear down my application to be able to see those changes in real time. So it's been developed for development. It's there so that we can have agile, iterative development and see those changes as they happen. So that's why I've run these in dev mode. So I've run both the inventory and the system microservice in dev mode, and I know they're up and running when I see this sort of line of stars and the lovely message, Liberty is running in dev mode. So both of them are up and running, and what I've also done is I've got a Docker command to get Jaeger up and running as well, so we can see the tracing information as we produce it in this Jaeger UI. So if I go back to the project here, so I've done these curl commands to sort of get my services running, so I know they're in there. and then if I go next, this is where we're actually going to implement the telemetry in our application. The first step is using the automatic implementation I told you about earlier. So because we're already using Jakarta RESTful Web Services, I can already implement telemetry without making any code changes. So to do that, what I need to do first is go to my server.xml, which I have open here. I'm just going to make it a bit bigger so you can see it. So here, the code that I'm missing is I'm missing this feature to enable MicroProfile telemetry. To make it easier and to make sure I don't introduce any bugs, I'm just going to copy everything and replace it and save. In this environment, you do have to manually save. It doesn't automatically save for you, so just bear that in mind. And the next thing I need to do, so that was for the service, the system service, and now I need to do it for the inventory service as well. So if I open up my server.xml, again, I'm adding in this MicroProfile telemetry feature to enable it in this microservice too. And if I go back to one of my, there we go, if I go back to, make this bigger, one of my terminals that had it in, you'll see that it's been updating as I've been making those changes. So again, no need to tear it down and replace it. Okay, so now that I've got those introduced in the server.xml, weirdly, and I don't really understand why they decided this, haven't really got my head around it. Weirdly, by default, telemetry tracing is off. So we have to turn it on, which I find a bit odd. But to do that, we're going to be using MicroProfile configuration. So we have an external configuration file so that we can easily access it and we don't have to trawl through all our code to be able to see it. So I'm going to use this touch command to be able to create that MicroProfile config properties file, this time in the system microservice. So if I open that up, make this smaller again. So in here, I'm going to add these 2 bits of configuration. So we're just giving it the name of the service here, which in this case is system, and we're turning the disabled to false, which means it's on, because that makes sense. I don't know why. So now we need to do it for the inventory microservice. So again, we're going to open it up. In this case, I already have some configuration in there. I'm just going to add those 2 additional, those 2 additional pieces. So again, in this case, the only difference we've made here is it's a different name for the service, because this time we're in the inventory service. Okay, so now I can do this last curl command. So if I do that curl command, it basically invokes my system and inventory services. And now I can either click this visit Jaeger service, or, because I've already got it open, I can go back, refresh. Here we go. Perfect. Still connected to the internet, which is good. Go to inventory, find traces, and look, without any configuration or code changes, I've already got trace information within my application. And I can dive into that through the Jaeger UI and find out some more information about what's going on. Now, the next stages in the guide, which I'm not going to go through because of time, the next stages are going through the other implementation options. So using those annotations that I talked about, and with CDI injection, and also using the agent instrumentation as well, which is, I think, on the next one. Yeah. We've also got some tests, just so you can make sure your application is working as expected, because we're all, best practice developers, and we test everything. Yep. Don't deny it. So we got some tests in there if you really want to try them. The nice thing is, with Liberty running in dev mode, to run the tests, all you need to do is hit enter, and it will run those tests for you. We didn't want it to run all the time, because it's kind of annoying if it's running after every configuration or code change. So we wanted to make it a deliberate command that you enter when you're in dev mode. So it's that enter command that does it, and luckily, right now, all our tests are running. Hooray. Although I didn't make that many code changes, so kind of makes sense. At the end of all of our guides, we have instructions to shut down Docker if you've got Docker running in that, and to also remove the repositories that you have within that particular environment. Please follow these, because if you want to go onto another guide, it'll mess up your environment and it won't know what's going on. Alternatively, you can just log out and it kills your whole application and anything running. So just make sure you do that if you want to try multiple guides all in the same session. Okay, so now that I've shown you that, I'm going to go back, but this time I'm going to do it really quick, because nobody saw that transition. Cool, okay, so in summary, because we're now at the end of the session, thank you for sticking with me here. In summary, hopefully what I've shown you is that we are entering a more complex and complicated world of software development, but that we can learn lessons from biology and medicine to hopefully implement better practices and tools and technologies that can enable us to create better, more efficient and effective cloud-native applications. Effective observability is critical to that, to enable us to actually understand what's going on in this complicated environment so that we can more effectively debug our applications and make them better in our production environments. To do this, context is critical. We can't just be using logging and metrics. We've got to be looking at things like tracing as well to be able to gain that all-important context. But the nice thing is, there's no excuse, because there's open source tools available. I love it. So, hopefully, even if you can't use it right off the bat, hopefully, utilizing those guides that I showed you, you can at least try it out and see what it's like for size and see if it would suit your application and fit with it, and sort of see if you could use it in the future in your production environments. As if I didn't give you enough homework with all the links I've included all throughout, there's more for all those keen beans, the ones who raise their hands quickly. Love it. So for those who want to find out more about sort of observability and get right to the basics and have that refresh, the first link's useful. Second link's useful if you want to deep dive into that MicroProfile spec I just showed. And the third one shows you that with the demo example that I showed as well. You can also head to those Open Liberty guides if you want to try out that guide as well. openliberty.io/guides, or just go to openliberty.io and you'll find them all there. If you do want to connect with us, please do. I run these accounts. I'll say hi. So you can connect either on Twitter or LinkedIn, or alternatively, if I don't get around to your questions after this, feel free to reach out to me personally as well. Grace Jansen 27 is my Twitter handle. I'm on LinkedIn as well. Feel free to connect and reach out. Just let me know you were in the audience, and then at least I know that we know each other. Cool. But with that, I'm going to say thank you very much for your time today. I really appreciate it.